Assalamu alaikum, sir. Today I will explain my DLC assignment named of Digital Parking Control System project. It counts car entering and exit a parking garage. When full, it shows full on display. If space is available, it blinking space available shows on display. So my first question is My first question, block and flow diagram. This part asks for a step-by-step plan to design the parking system. We need to draw diagram showing how the counter sensor display work together. So my first question answer block diagram shows all shows all part of the parking control system connected work together. So max car capacity A plus G plus H. A means 2, G means 6, and H means 1. That means 9 cars. So decimal to binary 9 to 1001. We will create block diagram for 4-bit including comparator. And if started and convert two decimal number into binary using 4 into 16 into 4 encoder. And it start the maximum car capacity keep at that is parking capacity 10 cars. The entry and exit sensor feed data into a 4 bit up down counter which car parking match which car parking match sensor and 4-bit up down counter. A comparator the binary A and B. A and B. A comparator checks if current car count match the maximum capacity. If the garage is full, timer 1 actives the full display. If space are available, timer 2 trigger are the blinking space available the display. So second part is the flow diagram. The flow diagram also included the essential component like an encoder to process keypad input register to store values and register to store values and clock to synchronize operations. Each block has a specific role. Each block has a specific role, ensuring the system accurately and monitoring parking flow of the data control signal between different part of the system. So, first question, last part, the up down 4-bit architecture of 4-bit asynchronous up down counter. For the counter design question, one 4-bit up-down counter is used to be a 9 cards which requires 4-bit JK flip-flop. Since 2 to the power 4, that means 16, greater than or equal 16, greater than or equal 9. Each JK flip-flop toggles based on the clock and previous state, enabling synchronous countering. So my second question is focus on 555 timer, duty cycle, and 7-segment display to recognize it's about circuit design and the parking system. So first calculate the derived values for 555 timer stable given duty cycle D. Duty cycle means 100 minus P and P means A plus B plus C plus D plus E plus F into 2. That means A equals 2, C equals 5, and D equals 1, and E equals 1, F equals 0 into 2. But if any value 0, then replace by A plus B plus H, 2 plus 3 plus 1, that means 6. But replace 2, replace F is 6, that means P is 30%. Then D equals to 100 minus P, that means 100 minus 30 equal 70%. And frequency means A plus D plus 2. 2 plus 1 plus 2, that means 5 hertz, and t equals 1 by f, and 1 by f equal to 0.2 equals 200 millisecond. We know duty cycle, th divided by ts plus tl equals and ts समान equals to at 140 ms. The display will be for the TS 140 ms. Again, T equals TS plus TL. That means TL equal to 60%. The display will be of TL 60 millisecond. For 215 microfarad capacitor used to, and R2 equals to TL divided by 0.693 into C. That means that means 346.33 capacitor, and R1 calculate 461.76, and step by step 470 capacitor, then 400 microfarad, and 15 microfarad, then calculate 3 capacitor value. Then the capacitor 215 is the best choice from the given capacitor, from the given capacitor 15, 215 microfarad and 470. The capacitor provides resistor to obtain and space for the timers. It achieve and duty cycle 70, and R value matches from R value matches from the 5 hertz average time on the 140 ms on the 16 ms for TL off. The 470 capacitor of the low resistor drawing the current 15 and show very high resistor. So my third question is FSM and HDL code. So my first question, the required state machine designed to control the display output A and B and its Verilog code, ensuring its flow given time limits. So state diagram as it is, and state table, present state table, reset, and first column is reset, second column is present state, and third column is next state, and final last column is output state. So explain this table, and the FSM to clearly define state table where A is active for duration of TH equals to 4 millisecond, and state B where output is B is active for TL equals to 4 millisecond. I created a state diagram to visual represent to state and translation and state table that define that current state, the next state output or B, and counter values required for the state transition. To implement FSM, the equation part to implement FSM, I wrote Verilog code with state register, counter, the next determine based on the whether counter reached the value of TH or TL. Switching between states A and B. The NS0 reset P2 bar, P1 bar, P0 bar plus P2 bar plus P2 bar plus P1 plus P0 bar plus P2 dot in P2 dot P2 P1 bar but P0 bar plus it is same as NS1, NS2, and output states A and B. Then Verilog code is module, first choice module module TLC binary. This is syntax. This is Verilog code syntax. Then the output is a simplify assigned as a when each state A and B. When each state B, the counter resets on a very state transition, ensuring precise the timing each output period. Then assign the next state. Next state is the Verilog code next state, the step by step, the next state one, next state two, next state zero. Then the output state, output assign the present state diagram. Then the output state is the logic output state logic assign output A, then represent assign output A, then assign represent B, then output logic B represent B. This and finally AND module. This is actually Verilog code syntax. My assignment last part, limitation and upgrades. Finally we analyze the system weakness like the small capacity and suggest improvement like adding microcontroller for the larger parking areas. So limitation parts answer is the 555 timer lacks of the control or enable signal, making it unsuitable for the dynamic digital control. The current counters of the limited to handling only up to 9 cards. The system does not support real-time data logic and remote monitoring capabilities. Then modification, replace 555 timer with a microcontroller. Replace 555 timer with a microcontroller for better timing control and programmability. Integrate sensor with microcontroller to add feature like data logic and based on monitoring. To use the system in larger parking, to use the system larger parking areas, we need to add more sensors and split area into uh, zones, and zone can have own sensor and display. We we should also use a central system to manage all the zones together. This way, the system can handle more cards and give better control and information without getting confused or slow. Control or slow. So use D-type latch between the timer output and the 7-segment display. 7-segment display. The higher number of cards, 255 and 8-bit, then use encoder 8-bit, counter 8-bit and comparator 8-bit. So thank you. Thank you so much. Assalamu alaikum, sir.